with the solving single variable equations with the distributive property. And in a previous exercise, we just simplified expressions using the distributive property, but this time we're actually going to solve it. We're going to come up with an answer. For example, in number 1, eventually n is going to equal some number. But the rules for distribution are the same. So the first thing we do is distribute this -4 to both terms inside the parentheses, and we draw our distributive property arrows, our distribution arrows, so we don't forget what we're doing. Since it's an equation, we are going to take our ruler and draw a straight line very faintly. It's kind of a guideline. So we keep those equal signs nice and lined up. And here we go. So we have -4 times 2. So we have -4 times 2 plus -4 times -5n okay, and that equals -148. Okay, so let's simplify this down. -4 times 2 is -8. So we have -8. Negative times a negative is a positive. So -4 times -5 is positive 20. So -4 times -5n is positive 20n. So we'll put plus 20n. Okay, equals -148. All right, so now we want to peel the onion from the outside in. I want to get to that n right there. It's being multiplied by 20, and the 20n has -8 added to it. So I want to get rid of this -8. So I have to do the inverse operation of subtraction. In other words, I'm going to add 8 to both sides of the equation. Now, on the left, it's very easy. These just kind of cancel out, okay? On the right, though, we have to think, I've got this huge negative number and I'm adding 8. So I'm basically subtracting 8 and the result's negative. So if you want to think about it, you're just performing a subtraction problem. So 148 minus 8 is 140. So that'll be -140. And over here, I've got 20n. So I've got 20n equals -140. Now remember, the 20 is glued to the n with multiplication. So I want to unmultiply the 20 and the n, which means to divide both sides by 20. Okay. Well, those 20s cancel out right there. And I've got n by itself, which is great news. Okay. So n equals, and now I need to reduce this. Well, 20 goes into 100 5 times. it goes into 126 times, so it must go into 147 times. So if I were to cancel these two in numerator and denominator, and basically divide 140 by 20 and 20 by 20, I leave behind a 7 here and a 1 here, so n equals -7. Okay? And that's number 1. And we're moving on to number 2. All right, so here we're going to have some distribution and then some combining of like terms. All right, whatever. This time the variable is on the right side. No problem, it's fine. So we'll just write 101. Nothing happens to that just yet. Equals. And then I have to do my distribution arrows from 3 to -8p and 3 to -1. So I've got 3 times -8p plus 3 times -1 minus 2p at the end. Okay, that just comes along for the ride. Okay, so let's keep going. We've got 101 over here. Nothing happens to this just yet. Equals. Now 3 times -8p is -24p. So we'll put -24p. 3 times -1 is -4. -4. And then minus 2p. We have some like terms that we need to combine over here. The -24p and the -2p go together. -24 plus -2 is -26. So what I've got here is 101 equals -26p minus 4. Trying to get to the p, okay? But first I gotta get rid of the -4, so we'll do the inverse operation and add 4 to both sides to keep the equation in balance. Okay? So on the right, those -4's cancel. Over here, I've got 101 plus 4 is 105. So 105 equals -26p. And now I need to divide both sides by -26 to get p by itself. Cancel, cancel. And so p is going to equal whatever this reduced fraction is. Well, 26 is 13 times 2. And I'm wondering if 105 is divisible by 13. Let's see. 13 times 10 is 130. So 13 times 9 is 117. 13 times 8 would be 117 minus 13. Give me 104. Let me check that. Thirteen times 8. 24. Yeah, 104. Okay. So if I pull the 13 out, I'd still have a remainder of 1. If I pull the 13 out here, that would leave behind a 2. So I could say P is equal to this. That's fine. But I was thinking P is equal to -8 and 1/2. See what I'm saying? Because I'm dividing out here. I wonder if that will allow you to do that. No, that doesn't work. We'll just leave it like that. Negative 105 over 26. Okay. And we'll put that in a box. Alrighty, moving on to number 3. And we're going to distribute 7 and then combine like terms and then solve. Okay, so we're going to distribute the 7 to the x and the 7 to the 1. And so we're going to have 8x plus 7 times x, which is 7x, plus 7 times 1, which is 7, equals 127. Okay, well, the 8x and 7x can be added together to make 15x. So I've got 15x plus 7 equals 127. And I'm going to subtract 7 from both sides. And I'll have 15x equals 120. And then we'll divide both sides by 15. Giving us x equal to 100 over 15. And the way I would go about this is to say, I would break this down, and I would say that this is, 12 times 10, which is 12 is 2 times 2 times 3, and 10 is 2 times 5. So this is 2 times 2 times 2 times 3 times 5 over 3 times 5. And I can just cancel all the terms that are the same, leaving behind 2 times 2 times 2, which is just 8. So let's make sure that 15 times 8 is 120 before we commit that to paper. I got 120. Yep, so x equals 8. Okay. Moving on to number 4. We need to kind of carve out our workspace here. Okay, so we have 96 equals this. We're going to distribute the negative 6 to both of these terms. And so we'll have 96 equals negative 6 times 3n plus negative 6 times negative 4. Okay, well, that gives me 96 equals 6 times 3 is 18, so negative 6 times 3n is negative 18n. Negative 18n. And then negative times negative is positive, so this is plus 24. All right, well, next step is to subtract 24 from both sides. And 96 minus 24, that gives 2 and 7. So I got 72 equals negative 18n. And so I'm going to divide both sides by negative 18. Canceling out the negative 18s right here. All right, now I just have to work with 72 over 18. I'm going to move this over here. I got negative 72 over 18. Okay. Well, 72 is 9 times 8, which is 33222. Or in other words, it's 2223. That's the prime factorization there. And then 18 is 3 times 6, right? So that's 2 times 3, which is 6 times 3. So 233. 233. See the power of this prime factorization? Because now I can just go in here and say cancel, 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 cancel. And it leaves behind 2 times 2, which is 4. So negative 4 should be the answer. And just to check that, we'll do 18 times 4 and make sure we get 72. And we do. So negative 4 equals n. And the other way to write that is n equals negative 4. Those are identical. You're allowed to do that. Okay. All right, that's number 4. Moving on to number 5. Number 5, ladies and gentlemen. All right. Oh, this looks fun. So we're going to distribute the 7 to the 4 and the 7 to the 7x. Let's see where this takes us. Okay, so the left side we're not going to touch. Just going to make it a little bit bigger. Negative 7x minus 28 equals 7 times 4, which is, well, let me go ahead and write it. 7 times 4 plus 7 times 7x. All right, so the left side doesn't change, negative 7x minus 28 equals 7 times 4 is 28. And 7 times 7x, well, 7 times 7 is 49, so 7 times 7x is 49x plus 49x. Okay, so we're going to need to move this negative 7x over here to hang out with this 49x, and move this 28 to go hang out over here, okay? So what we're going to do is add 7x to both sides. See, we got x on both sides of the equation, plus 7x. And we know that this is going to give us 56x, right? So what we got is negative 28 equals positive 28 plus 56x. Now we're going to subtract 28. Cancels right there, but here you have two negatives. So you've got 28 plus 28 is 56, but it's negative. Okay, so it's negative 56 equals 56x. Okay, so what I'm going to do now is to get x by itself, I'll just divide both sides by 56. Okay, well, 56 over 56 cancels. And now I've got 56 over 56, but I've got this negative hanging out. So when I cancel this down, I'm going to leave behind a negative 1. All right? So the answer is negative 1 equals x. So we're going to go ahead and put that in a box. That was a cool problem. All right, well, that was number 5. Moving on now to number 6. We've got variables on both sides of the equation, so just keep that in mind as we do our distributive property. Here we're going to distribute the 7 to the 2k and the 7 to the 5. And then we'll just deal with the rest of it. All right, so first I'm just going to write negative 35 plus 7k equals 7k. See, I'm not changing anything. And now I'm going to start to change things. So plus, and then we have 7 times 2k. We'll put that in parentheses. Plus 7 times 5. All right, so you can barely see the whole problem there. All right, so we'll rewrite the left side. Nothing happens here. We have negative 35 plus 7k equals 7k. And then 7 times 2k is 14k, so plus 14k. And then 7 times 5 is 35, so just plus 35. Well, we can add 7k and 14k, make 21k. All right, so we can group these and add those together. So we'll just rewrite the left side. Again, nothing changed. Negative 35 plus 7k equals 21k plus 35. Things are starting to come together, aren't they? So let's gather, so we avoid the, it really doesn't matter. So anyway, I think we should subtract 7k from both sides. Cancel. Now we have negative 35 equals 14k plus 35. Now I'm going to subtract 35 from both sides. On the right, those cancel, but over here I've got negative 70 equals 14k. Okay, and I'm thinking that it's going to be 5 because I'm going to divide both sides by 14. And let me just check 14 times 5. Yeah, that's definitely 70. And so when these cancel, k is by itself now. So k equals, and then remember, when I cancel this down, I'm going to leave behind a negative 5. Okay, so k is negative 5. Very cool problem. All right, this is algebra, guys. And this is cool. All right, so we are now turning the page onto the final 4. And here on number 7, we're working with a V. And what we're going to do first is we're going to make this minus sign a negative 1. Group him. And so now we're distributing a negative 5 to this term, these terms, and then the negative 1 to these terms. So that'll help us out. 2 distributions. Okay. So we'll go ahead and drop that line there. I've got 12 equals, and then here we go, negative 5 times V plus negative 5 times negative 6 now we're doing this one, plus negative 1 times negative 2 plus negative 1 times negative v. I'm going to put it here. Negative 1 times negative v. Kind of run out of room there. Okay, so the next, when we rewrite it, it'll be a lot less space. So on the left, we've got 12. Equals, well, negative 5 times v is negative 5v. Negative 5 times negative 6, positive 30, so plus 30. Negative 1 times negative 2 is plus 2. And then I've got negative 1 times negative v, which is positive v. So plus, and I'm going to put 1v, just to make it really clear. And so now I can combine the 30 and the 2, and the negative 5v and the 1v. All right? So I've got 12 equals negative 5 plus 1 is negative 4. So I got negative 4v. And then 30 plus 2 is 32, plus 32. Well, the only thing to do is to subtract 32 from both sides. On the right, that cancels, but on the left, we're going to end up with the negative number, so we need to do 32 minus 12 and just make the answer negative, and that's going to be negative 20. So we have negative 20 equals negative 4v, and dividing both by negative 4 to get the v by itself. I cancel out my negative 4s, and I've got v equals negative divided by a negative is a positive, 20 divided by 4 is 5, v equals 5. How cool that it just all came down to that. Okay. Very, very cool. All right, so we're moving on to number 8. Oh my goodness. So we got two distributions. We're going to distribute the negative 7 to the 2m and to the 8. And we're going to distribute the 8 to the negative 1 and the 5. Here's our little drop down there. 66 going to be hanging out by itself on the left for a little bit. Just chill out here, brother. Now I've got negative 7 times 2m plus negative 7 times 8 plus, now we're moving on to this one, 8 times negative 1 plus 8 times 5m. Okay, so there's the whole right side. It's going to look a lot better when we clean it up. Okay, so we got 66 equals negative 7 times 2m is negative 14m. Negative 7 times 8 is minus 56. 8 times negative 1 is minus 8. And then 8 times 5m is plus 40m. Well, pardon me. I've got negative 56 minus 8 as common terms, and then a negative 14m and a 40m. We'll have to combine all this together. So negative 56 minus 8 is like 56 plus 8. 56 is 7 times 8, so 56 plus 8 would be like 8 times 8. That's going to be like negative 64. So on the left, I've still got that 66 hanging out. Equals, and we'll just do one thing at a time. I got negative 14m. I'm going to move the 40m over next to that. And then we said minus 64. Perfect. Well, 40 minus 14. Think about it this way. 40 minus 10 would be 30. So 40 minus 14 would be like 26, right? But if you aren't sure, you can do 40 minus 14. And you can show yourself that this can be 26. So we have 66 equals 26m minus 64. Okay, so I want to plus 64 on both sides. Cancels out the 64 over here. What am I going to have? 6 plus 4 is 0. Carry the 1, 12, 13, 130. And I'm guessing that 26 times something equals 130. Okay. And I'm guessing it's 5. Here's how I'm guessing that. 5 times 20 is 100. 6 times 5 is 30. So 26 times 5 must be 130. Divide both sides by 26. And we cancel those 26s, leaving behind m equals, and then 130 divided by 26 is 5. So the answer is 5. And just to be sure, we don't want to make any mistakes. So we're going to take 26, multiply by 5, and just check, because what possible harm could there be in doing that? And we got it. So we're very confident there. All right, moving on to number 9. Oh, joy. Looks like we're going to have variables on both sides of the equation. So first I'm going to distribute this 8 to the 1 and this 8 to the 4b, then 4 to the 4 and 4 to the 8b. Okay, so I've got, what have I got going on here? I've got 8 times 1, that's just 8, plus 8 times 4b, it's going to be 32b, plus 8 equals 4 times 4, that's going to be 16, plus 4 times 8b, that's going to be 32b. Okay, so let's simplify everything down. So we have 8 plus 32b plus 8 equals 16 plus 32b. Okay, now notice something. I got plus 32b on both sides. If I subtract This is a special type of problem. I'm going to go ahead and subtract 32b. I wanted to show you guys these two weird problems. Okay. And notice how they cancel out. So the variables just canceled out, and there's no b left. So now I just have 8 plus 8. Well, 8 plus 8 is 16. And 16 equals 16. So the key thing to do is when you get into a situation where you've eliminated your variables and you're looking at numbers, what you want to do is you want to ask the question, is this true? Okay, is this true? And the answer is yes. And so the answer to the question is all real numbers. So that's kind of a weird one. And I wanted to show it to you so you could see how it evolves. Okay. All real numbers. Another way of writing all real numbers is to put this symbol. That's the symbol for all real numbers. All right. So that's 9. It's a weird one, right? For sure. So, but this is the answer. All real numbers. Now, when you ask the question, is this true? If the answer is no, if this is like 16 equals 100, then the answer would be no solution. But if it is true, it's all real numbers. So same number equals same number, all real numbers. Number equals different number, no solution. Let's take a look at number 10, the last problem. Okay, so first thing I'm going to do is I'm going to go ahead and draw these distribution arrows. The negative 4 is going to be distributed to the 6k and to the 7. 6 going to the 1 and the negative 4k. And let's see what happens. So on the left, I've got negative 4 times 6k plus negative 4 times positive 7 equals, and then on the right I've got 6 times 1, that's 6, plus 6 times negative 4k, negative 24k. Okay, so there's everything. Now let's just simplify it down. Negative 4 times 6k is negative 24k. And negative 4 times 7 is minus 28. Now I've got 6 times 1 is 6. And then I've got 6 times negative 4k, which is negative 24k. Okay, it's the same situation I had in the last problem. If I add 24k, it doesn't matter what side, it's going to cancel out over here, and it's going to cancel out over here. And it's going to leave behind these two numbers, negative 28 equals 6. Okay, so here's what you do. Is this true? Does negative 28 equal 6? No. So the answer is no solution. Okay, no solution. This is not true, so no solution. All right, now that brings us to the end of this really exciting, fun algebra that we're doing. I'm so excited that we're doing these algebra problems. Thank you so much for watching, and I hope you gained something from this.